back to my channel. In this video, I am going to discuss about illustrating arithmetic sequence. But before we illustrate arithmetic sequence, let us define what is an arithmetic sequence. Arithmetic sequence, a sequence in which term after the first term is obtained by adding a constant term called common difference, denoted by D. Examples: number 1, 2, 3, 4, 5, 6, 7, and so on. Why is it that it is an arithmetic sequence? It is an arithmetic sequence because it is added by 1, in which 1 is a constant number added to each term to get the next term. Okay, 1, we have here the first term 2, plus 1, 3, plus 1, 4, plus 1, 5, plus 1, 6, 6 plus 1, 7, and so on. Next example, 3, 5, 7, 9, 11, 13. It is an arithmetic sequence. Okay, 5 is obtained by adding 2 from 3. So 3 plus 2, we have 5. 5 plus 2, 7. 7 plus 2, 9. 9 plus 2, 11. 11 plus 2, 13. And so on. Next example, 4, 7, 10, 13, 16. It is an arithmetic sequence because it is added by a constant number 3. That is the common difference. So we have 4 plus 3, 7. 7 plus 3, 10. 10 plus 3, 13. 13 plus 3, 16, and so on. Another example, 2, 0, negative 2, negative 4, negative 6, and so on. It is an arithmetic sequence because each term is added by negative 2 to obtain the next term. So we have 2 plus negative 2 is 0. 0 plus negative 2 is negative 2. Negative 2 plus negative 2 is negative 4. Negative 4 plus negative 2 is negative 6. Number 5, 1 half, 1, 3 halves, 2, 5 halves, and so on. This is an arithmetic sequence in which the common difference is 1 half. Each term is added by 1 half to obtain the next term. Okay, so 1 half plus 1 half, that's 1. 1 half plus 1 half, that's 3 halves. 3 halves plus 1 half, that's 2. 2 plus 1 half, that's 5 halves. First term is denoted by a sub 1. This is called first term. And the second term is denoted by a sub 2. And the third term is denoted by a sub 3. And the fourth term is denoted by a sub 4. And for the fifth term, a sub 5. For the sixth term, a sub 6. Until a sub n, where n is from 1 to infinity. Continues. Okay. Arithmetic sequence is a sequence in which term after term is obtained by adding a constant term called common difference. So if we have the first term here, a sub 1, we can say that a sub 2 is a sub 1 plus d. Okay? So the first term is a sub 1, and based on our definition that a sequence, term after the first term is obtained by adding a constant term called common difference. So we can get second term by adding common difference from the first term. Okay. For example, 4. We get 7 as our second term because we added 4 by 3. 4 plus 3. So we can write here 7 as 4 plus 3. Where 4 is the first term and 3 is the common difference. So if we have here the general sequence, if we have the first term as a sub 1, so the second term can be rewrite into a sub 1 plus d. And also, a sub 3 could be a sub 2 plus d. Okay, why is it a sub 2 plus d? So you observe in example number 3, 10. 10 is obtained by adding 3 from 7. So we can say that 10 is 7 plus 3. And what is 7? 7 is the second term. Therefore, we obtain the third term by adding the second term by the common difference. And also, if we get the fourth term, we use the third term adding by the common difference. That's our fourth term. We can also write the fifth term by adding the fourth term by the common difference, and so on. Okay? Okay. In our next activity, let us determine if the sequence is arithmetic or not. If it is, find the common difference and the next three terms of the sequence. We have here number 1. Negative 4 is the first term, 3 is the second term, 10 is the third term, and 17 is the fourth term, and so on. Is this arithmetic or not? It is an arithmetic sequence. Why? Because the common difference here, we have a constant number here that is added to each term, that is 7. The common difference is 7. Okay, how do we get the common difference 7? Okay, as you observe, the first term is negative 4. Okay. We get 3 because we added 7 from the first term, negative 4. So we have negative 4 plus 7. The result is positive 3. By the rules in adding of integers. If the two integers have different signs, we are going to subtract the two integers. So since the sign of 4 is negative and the sign of 7 is positive, they have different signs. 7 minus 4, the result is 3. And copy the sign of the bigger number. The sign of the bigger number here is positive, so the result is positive. Now, we can also write here the third term, 10. We say 3 plus 7. 3 is the second term, right? 3 plus 7 is 10. It's correct. We can also write the fourth term as 10 plus 7. So what is common? The common here is we added constant term to each term by obtaining the next term. So we added negative 4 by 7 to obtain 3. We added 3 by 7 to obtain 10. We added 7 from 10 to obtain 17. So that is called the common difference. Okay? So we added common number or a constant number, a fixed number, and that is arithmetic sequence. Next example, number 2. First term is 10, the second term is 7, the third term is 4, the fourth term is 1, the fifth term is negative 2. It is an arithmetic or not? It is an arithmetic sequence. Why is it is an arithmetic sequence? Because each term is added by a constant number to obtain the next term. And what is that number? What is that common difference? The common difference is we added negative 3 to each term. Okay, how do we know that we added negative 3 to each term? As you observe, 10 is the first term. If we added 10 by negative 3, the result is 7. Okay, 7. Because, is it negative 13? No. Is it 13? No. Because the rules of algebra or the rules of adding integers, as I said earlier, if the two integers having different signs, we are going to subtract the two integers. So we have 10 minus 3, the result is 7. And what is the sign of the answer? Whatever the sign of your bigger number should be the sign of your answer. So here, the bigger number is 10 and the sign of 10 is positive, so the result is positive. Next, 7, if we added by negative 3, take note 7 is the second term. If we added 7 by negative 3, the result is 4. Same process that what we did in the second term. And our third term is 4. If we added by negative 3, the result is 1. And if 1 is added by negative 3, the result is negative 2. This is our first term, second term, third term, fourth term, fifth term. Don't forget that the first term is denoted by a sub 1, the second term is denoted by a sub 2, the third term is denoted by a sub 3, the fourth term is denoted by a sub 4, the fifth term is denoted by a sub 5. Example number 3. 2 is the first term, second term is 4, the third term is 8, the fourth term is 16, the fifth term is 32, and so on. Is this arithmetic sequence or not? It is not an arithmetic sequence. This is not arithmetic sequence. Not arithmetic sequence. Why? It's because there is no constant number that we added to each term. Okay. For example, if we add 2 by 2, 2 plus 2 is 4. If we added 4 by 2, the result is 6, but the next term here is 8. So we cannot say that there is a constant number added to each term to get the next term. So we do not say that this is an arithmetic sequence. This is not an arithmetic sequence because we do not have a common difference. Common difference is the number that we added to each term to get the next term. Okay, example number 4. 1, 5 over 4, 3 over 2. Is this an arithmetic sequence or not? Okay, it is an arithmetic sequence. What is the common difference? The common difference here is 1/4. So each term is added by 1/4 to obtain the next term. Okay, our first term here is 1. So if we added 1 by 1/4, it is a whole number added by a fraction. So we have a shortcut here. You are going to multiply the denominator to the whole number. 4 times 1, that's 4, plus 1, the result is 5. Then copy the denominator 4. That's 5 over 4. Okay? And 5 over 4 is added by 1/4. Take note, our common difference here is 1/4. So if we add 5 over 4 plus 1 over 4, these fractions are called similar fractions. And if we have similar fractions, we are going to directly add the numerator. So our numerator in the first fraction is 5. 5 plus 1 is equal to 6. Copy the denominator 4. Why is it 3 halves? Because 6 over 4, 6 and 4 have common factor, which is 2. So we divide 2 over 2 each number because that is the common number of each. So 6 divided 2 is 3, 4 divided 2, that's 2. So 6 over 4 is simplified into 3 halves. Okay, so therefore, this sequence is an arithmetic sequence in which the common difference is 1/4. Okay, example number 5. Negative 2, 1, 4, 7, 10. The first term is negative 2, second term is 1, third term is 4, fourth term is 7, fifth term is 10. Is this an arithmetic sequence or not? It is an arithmetic sequence. Why? Because we have the common difference that is added to each number, positive 3. So if we have, the first term is negative 2. We have here negative 2. So if we added negative 2 by 3 to obtain the second term, that's 1. And 1 added by 3, the result is 4. And 4 added by 3, the result is 7. And 7 added by 10, the result, and 7 added by 3, the result is 10. So the common number that we added to each term is 3. So that is the pattern. We can get the next term by adding the preceding term by 3 to obtain the next term. And that is called arithmetic sequence. Okay, in our next activity, we are going to find the first 5 terms of the arithmetic sequence given the first term and the common difference. Okay, number 1. The first term is 2 and the common difference is 5. So our first term is 2. Since we have the common difference 5, we can obtain the next term by adding the first term by 5 to obtain the next term. So 2 plus 5, that is 7. 7 plus 5 is 12. 12 plus 5, that is 17. 17 plus 5, that is 22. So this is the first 5 terms. The first term is 2, the second term is 7, the third term is 12, the fourth term is 17, and the fifth term is 22. Because we have first term is 2, the first term is 2, and the common difference is 5. Okay. Example number 2. The first term is 1. We have the common difference is negative 2. So the first term is 1. Since we have the common difference negative 2, we added 1 by negative 2. The result is negative 1. Okay? 1 plus negative 2 is negative 1. So negative 1 plus negative 2, the result is negative 3. The negative 3 plus negative 2, that's negative 5. And negative 5 plus negative 2, the result is negative 7. So this is now the first 5 terms of the sequence, having the first term 1 and the common difference negative 2. Example number 3. We have the first term 3 and the common difference 4. So that's simply the first term is 3. Then we add 3 by 4. That's 7. Okay? And 7 plus 4, it's 11. 11 plus 4, that's 15. 15 plus 4, that's 19. So this is now the first 5 terms of the sequence, having the first term 3 and the common difference 4. Example number 4. We have first term 5 and the common difference negative 3. So the first term is 5. The common difference is negative 3. So we added negative 3 each term. So 5 plus negative 3, the result is 2. Having different signs, subtract. So 2 plus negative 3, that's negative 1. Negative 3 plus negative 1 plus negative 3, the result is negative 4. Negative 4 plus negative 3, the result is negative 7. So this is now the first 5 terms of the sequence, having the first term is 5 and the common difference negative 3. Okay. In our next activity, we are going to find the common difference given 2 terms. Okay, example number 1. We have here the first term is 5 and the second term is 9. Now, we can easily find the common difference if the 2 terms are consecutive terms. When we say consecutive, nagsunod. First term, second. So they are consecutive. How to find the common difference if the 2 terms are consecutive terms? Just subtract the 2 terms. The common difference D is equal to the A sub 2 minus A sub 1. You are going to write first the second term first, subtracted by the preceding term. So here, our second term is 9. So we have 9 minus 5. The result is 4. So this is our common difference given our first term and the second term. Example number 2. Third term is 7 and the fourth term is 2. Are they consecutive? Yes, nagsunod sila. As I said, it is easy to find the common difference if the 2 terms are consecutive terms. When we say consecutive, sa ato pangadayo, like nagsunod. First, fourth, third, and fourth. So nagsunod. So, it is easy to find the common difference. Just subtract the 2. But write first the last term or the second term. You have 2 or A sub 4 minus A sub 3. What is A sub 4? That's 2. Minus, what is A sub 3? 7. The result is negative 5. 2 minus 7 is negative 5. Having different signs. Positive, negative. There's no rule in subtracting integers, but if we want to apply the rules, you're going to change the operation into addition. So this will become 2 plus negative 7. Why? Because positive times negative, negative ra gihapon. So 2 minus 7 is the same as 2 plus negative 7. So we apply the rules in adding integers. The sign of the two integers having different signs. So you are going to subtract. 7 minus 2 is 5. And what is the sign of the bigger number? The sign is negative. So our answer will be negative. So our common difference with this problem is negative 5. Okay. Now problem number 3 or example number 3. We asked to find the common difference with the given two terms. That is not consecutive terms. As I said earlier, that it is easy to find the common difference if the given two terms are consecutive terms. But how about they are not consecutive terms? How do we find the common difference? Let us go back with our idea earlier that if you say a sub 1, if we have a sub 1, we can get a sub 2 by adding a sub 1 by the common difference d. Okay? Now we can get a sub 3 by adding a sub 2 plus d. Okay? So in this case, we have no first term, so we use the second term. So a sub 2 next to a sub 2 is a sub 3, yes. And a sub 3 is obtained by adding a sub 2 by the common difference. And a sub 3 by the common difference to get the fourth term. And for the fifth term, a sub 4 plus b. Now, this is our second term, third term, fourth term, and fifth term. This is a long process, but we can solve this one. Okay, so here we can say that a sub 3. So I'm going to write here. I'm going to erase here. So here we can say a sub 3 is equal to a sub 2 plus d. A sub 4 is equal to a sub 3 plus d. And a sub 5 is equal to a sub 4 plus d. Okay? So this is our equation 1, equation 2, equation 3. Let us substitute the value of a sub 3 to the equation number 2. So let us substitute the value of a sub 3 to equation 2. So equation 2 will become a sub 4 equals a sub 2 plus d plus d. Okay? You observe? This is our a sub 3. Our a sub 3 is equal to a sub 2 plus d. Okay? So this will become a sub 4 equals a sub 2 plus 2d. So, this is now our equation number 4. This equation number 3 can be written as, or we can solve for a sub 4 here. You're going to transpose d to the left side. This will become a sub 5 minus d equals a sub 4. Okay? So therefore, a sub 4 is equal to a sub 5 minus d. So substitute this equation here into equation 4. So the value of a sub 4 is a sub 5 minus d. So you are going to substitute. So this will become a sub 5 minus d. Again, we obtain a sub 4 equals a sub 5 minus d from equation number 3. We solve for a sub 4. We transpose d to the left side, it becomes negative d. So a sub 4 will be left on the right side, and on the left side will be a sub 5 minus d because we transpose d to the left side. And this a sub 4, you are going to substitute this one into our equation number 4. So this will become, a sub 4 will become a sub 5 minus d equals a sub 2 plus 2d. Now what is a sub 5? We are going to substitute. A sub 5 is equal to 7. So it will become 7 minus d. What is a sub 2? A sub 2 is 1 plus 2d. So we are going to combine like terms. So 7 and 1 are like terms. Negative 2, negative d, and 2d are like terms. So what we are going to do is we are going to transpose each like terms para maato silang ma-combine. So here, we can say, transpose nato si 1, may mo siyang 7 minus 1. I-transpose nato si d, si negative d, may mo siyang plus d. So, ayaw mo kalibog, si 1, kung mag-aato silang interchange ang duha o position. Si 1 ibalin dito sa pikas, si negative d sa pikas. So, may mo siyang 7, matangtang si negative d, kaya itong ibalhin, ang napuli si 1. So, ang sign din ni 1, kaya i-transpose mo na ito, may mo siyang negative 1. Ang sign po na negative d, kaya ito mang i-transpose, may mo siyang plus d. So, baka, kanilang silang duha, ang atong di-interchange. So, nahimong minus, nahimong plus d. So, 7 minus 1, that is equal to 6. 2d plus d, the result is 3d. Since we are solving for the common difference na nakamantay 3, we divided both sides by 3 to solve for the common difference d. So 6 divided 3, that's answer 2. So therefore, a sub 2, or therefore the common difference is 2. Okay, example number 4, find the common difference given two terms. You have 3a minus 1 is the first term, second term is 3a, the third term is 3a plus 1. So as I said earlier that it is easy to find the common difference if we have consecutive terms. So now we can use here d, or the common difference, as a sub 2 minus a sub 1, and also d equals a sub 3 minus a sub 2. Okay? Then let us substitute. A sub 2 is 3a minus 1. 3a minus a sub 1 is 3a minus 1. Then we have here 3a minus 3a. Distribute the sign, plus 1. Okay. Then we have here 3a minus 3a is 0. It's 1. And then the other one, d equals, substitute the third term, 3a plus 1 minus 3a. d equals 3a minus 3a, combine like terms, the 0. So the remaining is 1. So they are equal. Therefore, the common difference of this problem is equal to 1 because they are equal. Okay, next activity. Find the value of a to make 3a plus 1, 4a, 6a plus 1, an arithmetic sequence. So we have three terms here. Let us use the idea of the common difference. So d equals, since we have three consecutive terms, so we have a sub 2 minus a sub 1. And the other one, d, is equal to a sub 3 minus a sub 2. Substitute, a sub 2 is 4a minus, what is our a sub 1? A sub 1 is equal to 3a plus 1. Don't forget to use the parentheses. Then we have 4a. Distribute the sign. This will become negative 3a minus 1. So we have here a minus 1. That's our common difference of these terms. How about the others? A sub 3, that is 6a plus 1 minus a sub 2, 4a. Okay, 6a minus 4a, that's 2a plus 1. And since we are referring on one sequence, therefore their common difference are equal. So d is equal to d. D is equal to d. Therefore a sub minus 1, a minus 1 is equal to 2a plus 1 because they have the same common difference. Then solve for a. We are going to combine like terms. So we can transpose 2a to the left side. This will become a minus 2a. And negative 1 to the right side will become 1 plus 1. So that's negative a equals 2. Since our a is negative, we are going to use this. We are going to make this one as positive by multiplying both sides by negative. So negative times negative a, that's positive a. Negative times positive 2, that's negative 2. Okay. That's our answer. Okay, next activity. Find the missing terms. Okay, for number 1, 2 is the first term, 5 is the second term. We have no third term, we have no fourth term. So what do you think is the third term? Is it 8? Why is it 8? Because what is the common difference in our sequence? The common difference is 3. We added 3 to each term to obtain the next term. So 2 plus 3, that's 5. By the way, as I said earlier, that common difference is very important to find the next term. We cannot find the next term of arithmetic sequence if we have no common difference. So how do we get the common difference in number 1? We have 2 consecutive terms here. So we can now get the common difference by using the 2 consecutive terms, the first term and the second term. That is a sub 2 minus a sub 1. A sub 2 is 5 minus 2. The answer is 3. So the common difference is 3. So 2 plus 3 is 5. 5 plus 3, that's 8. 8 plus 3, that's 11. So the missing terms of this sequence are 8 and 11. Okay? Number 2, what is next to 7? So we can get the common difference by using these 2 consecutive terms. So we have 4 terms. So we use d equals a sub 4 minus a sub 3. Our a sub 4 here is 22 minus a sub 3, 17, that is equal to 5. So the common difference is 5. So we added 7 by 5 to get the next term. That's 5, 7 plus 5, that is 12. So 12 plus 5, that's 17. 17 plus 5, that's 22. So 12 is the missing term. For number 3, 9 is the first term, but we have 2 consecutive terms here. So we can get the common difference. We have 5 terms. So the last term is a sub 5. So a sub 5 minus the fourth term, a sub 4. So a sub 5 is negative 7 minus a sub 4 is negative 3. So we have double negation here because our operation is minus and the sign of a sub 4 is negative. So it's negative 7. It becomes negative times negative. The result is positive. So here we are going to apply the rules in adding integers. The sign of 7 is negative, the sign of 3 is positive, so they have different signs. So subtract. 7 minus 3, that is 4. And what is the sign of the bigger number? Negative. So our answer is negative. So therefore, our common difference is negative 4. So we add negative 4 to each term. So 9 plus negative 4, the result is 5. 5 plus negative 4, the result is 1. So 1 plus negative 4 is negative 3. Negative 3 plus negative 4 is negative 7. So those are the missing terms. Okay, the next activity is the problem solving. So, I was advised by my physician to walk each day in the morning as my daily exercise. On the first day, I walked 40 meters. On the second and third day, I walked 60 meters and 80 meters, respectively, and so on. What is the distance I walked on the 10th day if I continue the pattern in my daily walk? So as you observe, we can observe the pattern. The first meters that I walked is 40 meters. The second is 60 meters. The third is 80 meters. What is the pattern? The pattern is we added a common number, that is 20. 20 meters. 40 plus 20, that's 60. 60 plus 20, that's 80. So what is the distance I walked on the 10th day if I continue the pattern in my daily walk? So if the pattern is continued, what is next to 80? That's 100 meters. What is next to 100? 120. What is next to 120? That's 140 meters. What is next to 140? 160 meters. What is next to 160? That's 180 meters. Next to 180, that's 200 meters. Next to 220 meters. Next to 220 meters, that is 240 meters. What is asked in the problem? 10th day. So this is the first day, second day, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th day. So this is our answer. This is our 10th day. So I walked 220 meters on the 10th day. Okay? That is how we are going to illustrate arithmetic sequence. So if you are new to my channel, especially to our students nowadays, do not forget to click subscribe and also the notification bell so that you will be updated for the more videos that I'm going to upload in my channel. So thank you for watching. Good day.